Hello everyone, in this video we will see problems of rectification related to parabola. So before we proceed, let us see how we can draw the parabola. So we have a parabola y square equals to 4ax. Let us first find out a vertex of this parabola. To find out a vertex, just see that when the left hand side and the right hand side of this equation will be 0. So the left hand side of this equation is 0 whenever y is 0 and right hand side is 0 whenever x is 0. So clearly vertex is 0, 0. Now we need to see that along which axis this parabola is symmetric. We can write down the above equation y square equal to 4ax as y equals to plus minus square root of 4ax. We are not supposed to take any negative value of x here in this case, because if we take a negative value then we will get a complex number here and we are working on a real line. So what we will do, we can just take only positive value. So you can just see that for any positive value of x, we will always get two values of y. One positive, one negative. If I put x is equals to a, so for x equal to a, we will get y is equals to plus minus square root of 4a square, that is nothing but 2a. So points we have here is a comma 2a and a comma minus 2a. So it will be downside. So clearly this parabola is symmetric along x-axis. We know the vertex is 0, 0. So the parabola will be like this. This is 0, 0, which is a vertex. Same way we can draw the parabola x square equals to 4aay. So here vertex is, now we can see that the left hand side is 0 whenever x is 0 and the right hand side is 0 whenever y is 0. Now let us find out the parabola is symmetric along which axis. Let us use the same technique that we have used here. So x square equal to 4ay. So we have equation x square equal to 4ay, that implies x is plus minus square root of 4ay. Okay, we are writing in this way just to identify that where will be the open part of the parabola, or we can see that where along which axis the parabola is symmetric. Now we can easily see that if I take any positive value of y, obviously we have to take only positive value, we can't take negative value, otherwise it will turn out to be a complex number. So if I take any positive value of y, you can easily see that we can get two values of x. One is positive and one is negative. If I put y is equals to a, I'll get two values of x as plus minus square root of 4a square, that is nothing but plus minus 2a. So for y is equals to a, we will get two values of x as plus 2a and minus 2a. So obviously this parabola is symmetric along y-axis and the shape will be like this. Clearly this is the vertex, which is 0, 0. So this is the way we can draw the parabola. It's really very easy to draw a parabola, but you can always write the equation of a parabola in this form to identify the axis along which the parabola is symmetric. Now let us see some examples related to this. Show that the length of the arc of parabola y square equals to 4ax cut off by line 3y equals to 8x is a into log 2 plus 15 by 16. In this example, we need to first draw the diagram. So here we have a diagram. As we know that y square equal to 4ax is the given parabola. Clearly y is plus minus square root of 4ax. So obviously for any positive value of x, we will get two values of y, positive, negative. So this parabola is clearly symmetric along x-axis. 3y equals to 8x is a straight line passing through origin, and it is somewhat like this. We want to find out the arc length of the parabola cut off by this line 3y equals to 8x. So obviously we need to find out the length O and A. O is nothing but the origin, so 0, 0. So let us first find out point of intersection of parabola and the line. We have two equations here. One is of a parabola and another one is of a straight line 3y equals to 8x. We will solve these equations simultaneously in order to find out the points of intersection. So let us take the two equations. Y square equals to 4ax and the another equation that I have is 3y equals to 8x. So x is clearly 3y upon 8. Now let us substitute this value of x equals to 3y by 8 in this equation of a parabola. So as y square equal to 4ax, that implies y square is equals to 4a 3y by 8, that I am substituting the value of x here. So this implies y square minus 3ay by 2 equal to 0. That implies y into y minus 3a by 2 equal to 0. Please do not cancel this y throughout, otherwise you won't get one point of intersection. So this implies y is 0 or y is equal to 3a by 2. Now we know the value of y. Let us find out the corresponding value of x. Let us use this equation 1. So from 1 we can say that x is equals to 3y by 8. So therefore for y equal to 0, as x is equals to 3y by 8 implies x is equals to also 0, and for y is equals to 3a by 2, as x is 3y by 8, that implies x is equal to 3 by 8 into 3a by 2. So the answer is 9a by 16. So here we have 2 points of intersection. So therefore 2 points of intersection are 0, 0 and 9a by 16. Always write down x coordinate first, comma 3a by 2. So these are 2 points of intersection. Let us write down all these points in the diagram. Okay, so already we have written 0, 0 point over here, and the point A is 9a by 16, that is the x coordinate, and y coordinate is 3a by 2. So we have the points of intersection and we need to find out the arc length OA. And we are finding here the arc length of a parabola. That means we have to consider the equation of a parabola. Equation of a parabola is y square equal to 4ax. Now we are supposed to use the formula of the rectification. So either we can write down x as a function of y or y as a function of x. But in our case, as we have equation y square equal to 4ax, it is always easy to write down x as a function of y or x in the form of y. So this implies x is nothing but y square upon 4a. Clearly here we can say that x is a function of y. So let us use accordingly the formula of rectification. The formula of rectification that we are going to use over here is S is equals to arc length OA. As x is a function of y, we need to use a formula in this way. It is integration square root of 1 plus dx by dy. We can integrate x with respect to y here because x is a function of y, the whole square, and here we have to integrate obviously with respect to y, and the limits that we need to write down, that will be also of y. In order to find out this integration, let us first find out what is dx by dy. As x is y square by 4a, that implies dx by dy is equals to 1 upon 4a is constant, and the derivative of y square with respect to y is 2y. So clearly we will get here y upon 2a. That is the value of dx by dy. So dx by dy, the whole square, is nothing but y square upon 4a square, the square of y by 2a. And then we need to find out 1 plus dx by dy, the whole square, that is same as 1 plus y square by 4a square, which we can write as 4a square plus y square divided by 4a square. Let us find out the square root of this, and then we will substitute everything in the formula. So square root of 1 plus dx by dy, the whole square, is equals to square root of 4a square plus y square divided by 4a square. Now here square root of 4a square we can write down directly in the denominator, that is 2a, and in the numerator we already have square root of 4a square plus y square. So therefore S is equals to integration y1 to y2 square root of 1 plus dx by dy, the whole square, dy is equal to integration. The value of a square root of 1 plus dx by dy is square root of 4a square plus y square upon 2a dy, and here we need to write down the limits of y. Let us see what are the limits of y from the diagram. The limits of y are 0 to 3a by 2. So let us put those limits over here in this integration, 0 to 3a by 2. These are the limits that we will have in this case. Now 1 upon 2a is constant, which I can write down outside the integration, and we will have inside the integration 0 to 3a by 2 square root of 4a square plus y square dy. Now here we need to apply one formula of integration, and that formula is this. It's a integration of x square plus a square dx is nothing but x by 2 square root of x square plus a square plus a square by 2 log of x plus square root of x square plus a square plus c. So let us use this formula in this integration. So let us first write down this in proper order. 1 upon 2a, 0 to 3a by 2, and I'm going to write down this as y square plus 2a the whole square dy. So it is like x square plus a square. Now let us apply the formula. So this is 1 upon 2a, then inside the bracket x by 2, so in our case it is y by 2 square root of x square plus a square, that is the original term, y square plus 2a square, that is y square plus 4a square plus a square by 2. In our case a square is nothing but 2a the whole square divided by 2 log of x is y in our case, plus square root of y square plus 4a square. We are not supposed to write c here because we have the limits 0 to 3a by 2. Now let us substitute the limits here. Before that, let us write down this equation properly by cancelling the terms. So y square plus 4a square that we will have here. Here 1 2 get cancelled out, and I'll get here 2a square log of y plus square root of y square plus 4a square, and limits are 0 to 3a by 2. This is equal to 1 upon 2a. Let us substitute the upper limit 3a by 2 in y. So we will get 3a by 2 into 2 square root of 3a by 2 square. So 3a by 2 the whole square plus 4a square plus 2a square log of 3a by 2 plus square root of 3a by 2 the whole square plus 4a square. So now let us substitute the lower limit 0. So we need to give the minus sign, put the bracket. Suppose if I substitute 0 here in y, I'll get 0 in the first term plus 2a square log of, at the place of y I'm going to substitute 0, so we'll get 0 plus square root of 0 plus 4a square. This is equal to 1 upon 2a, inside the bracket 3a by 4 square root of, this is now 9a square by 4 plus 4a square plus 2a square log of 3a by 2 plus square root of 9a square divided by 4 plus 4a square minus 2a square log of square root of 4a square, which is nothing but 2a. So this is equal to 1 upon 2a 3a by 4 square root of 25a square by 4 plus 2a square log of 3a by 2 plus again the same thing 25a square divided by 4 minus 2a square log of 2a. So this is equal to 1 upon 2a. Here I'll have 3a by 4 and this is into 5a by 2 plus 2a square log of 3a by 2 plus 5a by 2 minus 2a square log of 2a. This is nothing but 1 upon 2a 15a square by 8 plus 2a square log of 3 plus 5 8a by 2 minus 2a square log of 2a. So we will get 1 upon 2a into 15a square by 8 plus, here if I take 2a square common, this is nothing but log of 4a minus log of 2a. So this is equal to 1 upon 2a. If I take a square common, I'll get here 15 by 8 plus 2 times. Here I can apply property of log, that is log of a minus b is log a by b. So this is nothing but log of 4a upon 2a. So clearly this a get cancelled. So here this a also we can cancel out. So we will get the answer as a by 2 inside the bracket 15 by 8 plus 2 log 2. We can multiply by this 1 by 2 inside. So we will get 15 by 16 plus log 2. Let us see one more problem. But this time I'm not going to solve the whole problem. I'm just going to give you this problem as an exercise. But I'll just tell you which length here we are going to find out. To show that the length of the parabola y square equals to 4ax from the vertex to the end of latus rectum is a root 2 plus log of 1 plus 2. So the final answer is with you. You can solve by your own. So first of all, y square equal to 4ax, we need to draw this parabola. So as we know that we can write down this as y equal to plus minus square root of 4ax. So for any positive value of x, we will always get two values of y. So this is the shape of a parabola. It is symmetric along x-axis clearly. Then we need to find out what is a latus rectum. So latus rectum is the line which is perpendicular to the axis of a symmetry and passing through the focus. So here the focus is A, this is the standard parabola, and the line passing through this is nothing but the latus rectum. So this is clearly a latus rectum which is passing through A. So clearly we can easily find out what is the y coordinate of this point, that is point B, which is nothing but the end of latus rectum in this case. Okay, so what we will do, it is very obvious, as we know that x is equals to a, we can just substitute this value. So we will get y is equals to plus minus square root of 4a square, which is nothing but plus minus 2a. So clearly this point is a comma 2a, this point is a comma minus 2a. We need to find out the length of the parabola from vertex to the end of latus rectum. So we can consider either this point or this point. So I'm just considering this positive point. So I want to find out in this case arc length OB. So clearly we need to find out arc length OB. So S is nothing but arc length OB. So in this case I want to find out arc length OB, and also I know the end points 0, 0 and a, 2a. So based on the earlier example, one can easily find out this arc length. Now this is another example. Find the length of a parabola x square equal to 4y which lies inside the circle x square plus y square equals to 6y. So we have here the parabola as x square equal to 4y. Let us see the parabola is symmetric along which axis. So x is clearly plus minus square root of 4y. So we can easily see that for any positive value of y, we will always get here two values of x, positive and negative. If you substitute y equals to 1, you will get x is equals to plus minus square root of 4, that is nothing but plus minus 2. So for y is equals to 1, we will get two values of x as plus 2 and minus 2. So this is the parabola that we will have in this case. Clearly the vertex is 0, 0. Just see that when the left hand side and right hand side is 0, and clearly it is 0 for x 0 and y 0. Now we need to draw the circle x square plus y square equal to 6y as well, because we need to find out the length of the parabola which lies inside the circle x square plus y square equal to 6y. So first of all, let us convert this circle in a standard equation of a circle. So how to do that? This is x square plus y square minus 6y equal to 0. We need to make this perfect square because the standard equation of a circle is x minus a square plus y minus b square equal to r square. So we want to make this perfect square, and how to do that? So it's very easy to make such thing a perfect square. So suppose if you have something like ax square plus bx plus c equal to 0 equation, then one term you have to add and subtract so that this term you can convert it into the perfect square, and that term is nothing but middle term square upon 4 into first term. That is nothing but b square upon 4a. Let us use this technique for y square minus 6y. So we will get x square plus y square minus 6y. Middle term square means I am just considering coefficient. So the middle term square, the coefficient of middle term is 6. or minus 6, because we are taking here square, so it will be always positive. So 6 square is nothing but 36 divided by 4 into first term. The first term coefficient is 1. So here 4 into 1, that is 36 by 4. So I need to add and subtract 36 by 4. So we need to add and subtract basically 9. So x square plus y square minus 6y plus 9 equal to 9. So this is nothing but x square plus y minus 3 the whole square equals to 3 square. So clearly this is a circle with center 0, 3 and radius is 3. So let us draw the circle in order to find out the arc length. So this is a circle with center 0, 3 and the radius is 3, and we need to find out the length of a parabola which lies inside the circle x square plus y square equal to 6y. So let us call this point as A, this is O, that is origin, and this is B. We know that the origin is 0, 0. We need to find out in this case the arc length AB, which is completely lying inside the circle. So here we are going to find out the arc length of a parabola, and the equation of the parabola is x square equal to 4y. So this is the equation that we are going to use in the rectification formula. We can easily write down this equation in the form of x. Y is equals to x square by 4. Clearly this is a function of x. So accordingly we can use the formula of rectification. So we need S, which is nothing but arc length AB. So clearly you can see that this arc length AB is symmetric along y-axis. So it's absolutely okay if I find out the arc length OB only, and twice of OB is nothing but complete arc length AB. So S is equals to arc length AB, which is same as twice into arc length OB. Let us use the formula. So this is twice into arc length of OB. We will find out using formula of rectification, and that we are going to use it in this way. Square root of 1 plus, as y is a function of x, it is square root of 1 plus dy by dx, and here we need to write down the limits of x1 and x2. So we require the coordinates of O and B. We know the coordinates of O, but we don't know what are the coordinates of B. B is nothing but basically the point of intersection of circle and parabola. So we need to find out the points of intersection of circle and parabola by solving these two equations. So let us first find out that. Well, let us call this as 1. We will use this later on. So we have first equation of a parabola as x square equal to 4y, and another equation of a circle which is x square plus y square equals 6y. Obviously, whenever I need to find out points of intersection, I will use the simplified equation of a circle. So let us put this value x square equal to 4y in the equation of a circle. Put x square equal to 4y in x square plus y square equal to 6y. This implies 4y plus y square equals to 6y, and this implies y square plus 4y minus 6y equals to 0, which implies y square minus 2y equal to 0, which implies y into y minus 2 equal to 0. So this implies y equal to 0 or y equal to 2. As we know that x square is equals to 4y, for y equal to 0 we get x equal to 0, and y equal to 2 we get x square is equals to 4 into 2, that will be 8. So in this case x is nothing but plus minus root 8, that implies x is plus minus 2 root 2. Therefore points of intersection are 0, 0. One point is plus 2 root 2, 2, and the other point is minus 2 root 2, 2. Let us write down all these points in our graph. So we will get something like this. This is 0, 0, which I have already written here. This point is 2, root 2, 2, because this is a positive quadrant, everything is positive, and clearly the point A is minus 2 root 2, 2. We don't require point A in the rectification formula, because I am just going to find out over here the arc length OB instead of finding whole arc length A to B, because A to B arc length is symmetric along y-axis, so it is absolutely okay if I find out arc length OB only, and then arc length AB is nothing but twice of arc length OB. Let us use this formula now. So from 1 ace is nothing but twice into arc length of OB. So we require here point O and point B in order to find out the limits of integration. So twice integration square root of 1 plus dy dx the whole square dx, and here we need to write down the limits of x1 to x2. So this is equals to 2 into, now the limits x1 to x2 in our case is nothing but 0 to 2 root 2. So let us write down that over here. So it is 0 to 2 root 2, and here we need to write down 1 plus dy dx the whole square dx. Let us first find out dy dx. So as we have x square is equals to 4y, which we are going to write down y is equals to x square by 4. So clearly dy by dx is nothing but 2x by 4. 1 by 4 is constant, so obviously this is nothing but x by 2. Then dy dx the whole square is x square by 4. So 1 plus dy dx the whole square is 1 plus x square by 4. Let us cross multiply this. We will get 4 plus x square divided by 4. So square root of 1 plus dy dx the whole square is square root of 4 plus x square divided by 4, which we can write it in this way also. It is x square plus 2 square divided by square root of 4 is 2. Purposely I am writing in this way. Now let us substitute everything in the formula 2. So we have from 2, s is equals to twice of integration 0 to 2 root 2 square root of 1 plus dy by dx the whole square dx equal to 0 to 2 root 2, and the value of the square root of 1 plus dy dx the whole square is x square plus 2 square divided by 2 dx. Let us integrate this. Clearly this 2 I can take it outside, so 2 by 2 which get cancelled out, and the integration of 0 to 2 root 2 square root of x square plus 2 square dx. Again we need to apply here the formula integration square root of x square plus a square dx, that is x by 2 square root of x square plus a square by 2 log of x plus square root of x square plus 2 square plus c. So let us apply this formula. Here in our case a is 2, so let us apply the formula. So this is equal to x by 2 square root of x square plus a square, that is x square plus 2 square plus a square, that is 2 square by 2. So this 2 get cancelled out, log of x plus square root of x square plus 2 square. Complete the bracket, and the limits are 0 to 2 root 2. Let us substitute the limits one by one. We'll get the answer as 2 root 2 by 2. So by substituting upper limit we will get 2 root 2 by 2. 2 get cancelled, square root of 2 root 2 the whole square, 2 square is 4, plus 2 log of 2 root 2 plus square root of 2 root 2 square plus 4. Now let us substitute the lower limit, so we'll have minus sign. Please put bracket. By substituting 0 at the place of x, I'll get first term as 0 completely, plus 2 log of, in second term we will get this as 0 plus square root of 0 plus 2 square, that is square root of 4. So this is equal to root 2. This is the square root of 2 root 2 square is nothing but 4 into 2, that is 8 plus 4 plus 2 log 2 root 2 plus square root of again 8 plus 4 minus 2 log 2. So this is equal to root 2. Root 8 plus 4 is root 12 plus 2 log 2 root 2 plus root 12 minus 2 log 2. So here we can write down root 12 as 2 into root 3 plus 2 log of 2 root 2 plus root 12 is nothing but 2 root 3 minus 2 log of 2. I can take 2 common throughout so that we will get 2 into root 2 into root 3 plus log of, from this part if I take 2 common I'll get 2 into root 2 plus root 3 minus log 2. So this is same as 2 into root 6 plus log of, in this part I can use a property of log of a minus log b is nothing but log of a by b. So we will get log of 2 into root 2 plus root 3 upon 2. This 2 get cancelled and hence the final answer is 2 into root 6 plus log of root 2 plus root 3. Thank you.